All right, so for our next big unit test, I wanted to go over the solutions with you guys. So if there's anything that you are struggling with, you can kind of narrow in on it. So I'll probably take a little bit of time on each of the problems just to make sure that I'm really thorough about that. So anyway, taking off with question number one, in the first test, we had some problems very much like, as it turns out, this one right here, where we looked at it. And so again, I'm going a little bit out of order here, but you would probably notice that in the pattern of the values that is sitting here, it's always growing by 3 in terms of R. That's a fairly distinctive pattern. And actually, the first time I did this myself, I actually missed the fact that these are growing by 2s. So fairly significant little detail is it looks like I have a slope of 3/2 because my rise is 3 and my run is x. If I thought of this as x and this as y. And again, my y-intercept at 0 was -1 sitting right here. And you know, obviously we can then reduce this down and make y the letter R, and we could make x the letter N. I don't really think the R and X, R in X, Y is all that important. But one thing that I would encourage you to do is go into our calculator and let's try to see what happens if we check the equation that we came up with against the data that we have. And I think I'm going to go ahead and, just to be on the safe side, put that 3/2 in parentheses. And so if I go ahead and I look at my table, the question is, does this table actually work with the values that I was given? Notice that I plugged in 0, 2, 4, 6, 8 as my independent variables, and my dependent variables seem to match. So it seems that I did my problem well. Now, this other problem is a little bit harder because you'll notice that every single time we're moving up, it's not adding, but in every case, it's being multiplied by 3. So, and these are only growing by 1s. So anytime you have that constant multiplication, we're looking at some kind of an exponential story. And again, A is always our initial condition, which in this case should be the value at 0, which I got 2. And then we're consistently multiplying by 3. And so that, I think, should be my story. So it should be 2 times 3 raised to the x power if I've done that problem correctly. So again, like I did on the last problem, I'm going to go ahead and type my equation in. I'm going to go over here to my table, and again, I put my table in ask mode, but let's just ask about 0, 1, 2, and 3 and see if it in fact generates the table that I had, and it does. Last question here, let's go ahead and fix the letters here because instead of using x and y, we're using c and d, so this would be 2/3 times 3 to the c, and y is d. Last one, I know most of you are going to look at this and see very quickly that we're dividing every single time by 2, but that's actually the same thing as multiplying by 1/2. And so again, our initial condition happens to be 120. That's the time 0, and it'd be 1/2 to the x. But again, we can replace the value x with the independent value r, and y would be b. And just like the previous question, it doesn't take very long to do, so let's just go ahead and do that. 120 times 1/2 raised to the x power, and let's see if those values do generate what I see in my table. And you'll notice that 0 does give me 120, and it just lines out. I didn't put the -1 in there, but you could tell that that would work, and I can put it down here if I wanted to. So it's great. Number 2, this will be the last one for this video. We're just going to try to talk about what each of these things is. So when you look at the big 12 functions, which we had like x, we had x squared, x cubed, we had absolute value of x, etc. The parent function on this one is root x. That's the important function that's being moved around in this story. And so when I look at this, the first thing that I want to do is set this problem up according to the guidelines that we've established in class, which says never let anything be attached directly to x. And so as we go through our transformations, the first thing that I'm going to do is I'm going to take a look at the things that actually affect the y's. So my first transformation, that minus that's sitting right there, is a reflection across the x-axis. Remember that x squared, let me put that right here, hopefully we can see that better. X squared is this graph, but if you put the negative on the outside, negative x squared flips it upside down. So that negative sitting on the outside of the function flips the graph over. Okay. Second transformation I see is I look at this 2 that's sitting right here. Now that 2 again is sitting on the outside. That outside piece is actually going to double the y values. So it's a vertical stretch. And it's got a factor of 2. Now, if you said double the y values, I would totally accept that as well. I think that's not an unreasonable way to express yourself. My final piece that's actually happening to the y values is this 4 right here. And that's, again, if you just said up 4, I would totally get it and understand that. But technically, this is a vertical translation. Up 4. And so a vertical translation of 4 is fine. Now, again, I don't have enough colors to keep making all of the colors different, but now we're going to go to the inside. The first thing is, what does this 2 do? That is a horizontal compression. It's going to take all the x values, it's going to cut them in half, and then our last one is it's going to move it to the right 4. So again, that would be a horizontal translation. Again, it goes to the right 5. And that describes all of the bits and pieces that actually are attached to that idea. So I'll see you back for questions 3 through about 4 or 5. All right, bye-bye.